Okay, so this is part 2 for today. Okay, so this will be a little bit technical, and we got around 25 minutes, so we will catch up on this again next week. But underpinning security techniques for blockchain. So we learn about how fantastic the blockchain and the beauty of the first blockchain application, which is Bitcoin, right? But if we want to have that fantastic feature, then something innovative must be built underneath to make sure that all these features are valid, right? There are three the core cryptographic techniques used to build the blockchain, right? I have seen your syllabus, and I believe you guys have already in the first year you have studied a little bit of cryptography, right? So I think probably this session would be quite useful to refresh your memories, right? The first important one is okay, cryptographic cache function, right? Cryptographic cache functions such as SHA-256, right? This is the first important cryptographic function used in blockchain, right? So blockchain, even though it's invented, the technique is used to build the blockchain is not new. The important thing Satoshi did is he put these well-known security primitives properly to build an application, right? The first primitive he used is hash function. Second one is digital signature, right? And the third one is public key, PKI, right? Public key infrastructure or asymmetric encryption. So there's a link between the public keys, and he beautifully linked this public key infrastructure for digital signatures. Okay, so these are the three key security elements used to build the blockchain, particularly the Bitcoin. Okay, so what is hash function? The hash function is a mathematical function, right? It is a mathematical function. The mathematical function you can easily compute, right? So that let's say that mathematical function, let's denote that mathematical function H. Okay. So what input you will give? Any string, any data as a string. If you give any data as a string as an input to this mathematical function, right, it will output 256-bit message digest. The output would be 256 bits. Hope you can see this writing, right? So you can throw, let's say, 10,000 bits long string, okay, or even 1 million input. You can throw any size, okay. If you can input any size, it will always output 256 bits output. So that's a magic, beautiful hash function. Okay, beautiful hash function. So it's efficiently computable. So what are the security properties of hash? It is collision free, right? Because let's say you have two messages, M1, M2. So if you input M1, that will produce a one output. If you input the second message, M2, that will output another message. They both of them 256, right? You can't find, it is very, very difficult to find two messages. They are different, but they will output same 256 bit. It is almost impossible to find that. So that is called collision free. That's the first important property. The second property, okay, I think, so these are the two. Let me explain. So what is, sorry. So collision free, I mentioned before, you can't find two different messages. They will output same 256 bits. This is very important. This is a beauty of this hash function. It is nearly impossible. You can't find two things. Okay, that's the collision free. You have any question? And second one is the hiding property. Okay, cannot recover the message X. So from that 256 output, you can't recover the input message. Okay, you can't recover the input message. It is impossible. If you can recover it, you will get a Nobel Prize, right? It is quite difficult. So this is how it works. So, you know, there are a number of blocks in the mathematical function. Let's say I said, you know, your input message could be anything, right? It could be, you know, it could be 500, it could be 1 million bits, you know. So what happened is this hash function, especially this SHA-256, is break this input data into 512 bits, right? So you can have many blocks as you want, and they will go through a compression function over and over and over and again, and they will output finally 256 bits. Okay, 256 bits, right? So if you click, you know, if you click here, you will go to a web link where you can, there's a gentleman, he was kind enough to build an online portal where you can able to test. Let me do that for you. If I go to that website, let me share the screen as well. Okay, okay. Okay. So I hope you are seeing this one. Yeah. Hope you are seeing this one. For example, what you need to do is you need to go to key signature. I think I come to a wrong place. 1 second. Give me a second. Let me find the right link for. Can somebody confirm that you see this?
Yes, we can see it.
Okay, so this is a SHA-56, right? As I said, you know, whatever input you put, for example, this is a SHA, you know, you can type anything, you can see the input, the outputs are changing. It's always a fixed length, but you know, it's keep on changing. You can write as much as you want, but it will be keep on changing. It will always output a fixed 256 bits long output. Okay, that is the beauty, right? So how blockchain is actually using the hash function, right? It's using the hash function for two reasons. One is, you know, if you have a data that is varying in size, right? Some transaction must maybe small, and some transaction might be largest like this, and it is very difficult for you to track. Okay, so how the blockchain is using the hash is, whatever input you are giving, it wouldn't really bother about the input, but it will take the hash of the message and use this fixed 256 bit as an input, as an output, that the blockchain will record these hashes. Another beauty of this one is, for example, let's talk about this one. I'm going to change this n. Watch this hash value. I'm going to change this n into m. See, this hash function is completely changed. Even though I change only one data, one character in this input, it is completely changing the. So let me share this the link so that you can play around. So I think the link on the slide is not correct. So here we go. Play around with this one. You can see. Okay, and that's the first part. It is using hash to make sure that outputs are fixed size. Okay. The second useful thing that we will learn in probably next week or week after that is that this 256 is almost random. Okay, this 256 bits, even though it is in hexadecimal, if you change this hexadecimal into binary, it will go to all the 256 zeros and one, right? So what blockchain is doing is that it will enforce the minus. Do you remember minus? They need to create this hash function, but the first few bits must be 0. Okay, this is an important thing. We will repeat this again. And so if you want to get this first few bits to be 0, you need to find the input. You need to randomly input more and more different data, and trial and error. You do a brute force approach to make sure that you get an output in such a way that the output, the first few bits, that's the most crucial part, right? So, so we will dive deeper into this one probably next time, right? So, but play around with this. Okay, let me share the slides again. Okay, so that is the hash function. Right. Okay, let me finish off with the hash. So the first one is, read about this hash pointers. People use these hash pointers in databases, data structures, and hash pointers are one of the popular technique people use to reduce the data storage, increase the search efficiency as well. So, and in the blockchain, this is what happened. People, this is they input block, the first block, and that's the data for the first block, right? And what they will do, they will repeating the hashing mechanism to link this one. So this is the data. Okay, this is the data we care about. And let's say this is the hash of previous data. Then what happens is we will take a hash of all of them, right? I think the arrows are quite misrepresented. Let me come back again. Okay, right. So let's say we start from here. This is the time is increasing in this direction. Okay, so this is the block, first date block, right? This is the initial data. There are a lot of information written here, right? So this is the beginning. Right. So what happened in the blockchain is we will take the hash of this. Okay, we'll take the hash of it. Right. So we will take a hash of previous block. right? Now we have new data, right? Here we have more transaction, right? So now what we are going to do, so this is block 1, this is block 2. When we build a block number 3, what we will do is we will take the hash of this whole block and we will put it here. So we are linking the new block is linked to previous block. Okay, it's linked to previous block. And this is the link to the previous block, and this is the new data. This is the new data, right? What happened next? In order to, so this is how we build the third block. And if you want to build a fourth block, we will take all this data as well as this hash, and that goes into as a new transaction here, and the new data transaction will be printed here. In this way, we are linking previous data with the current data. Okay, so this is chain. If somebody change something, okay, let's say if somebody manipulated some of the transaction here, okay, if somebody manipulated this transaction, as I mentioned in the demo, even if you change 1 bit, the hash will be completely different. If somebody change this one, they are literally changing this one. Okay. If somebody change this one, then this will be changed, right? So you can have like thousands of 10,000 blocks like this. But if somebody change something in between, okay, somebody change one transaction, right, then people can easily identify that one. It's quite easy, right? Because if you're changing a single bit here, will change the completely everything. Okay, so that is the first and important use of hash function in the block. So you can see blockchain, these are the block, and each block linked to the previous block via hash mechanism. Okay, and there's another important thing is I suggest you to have a look at this one, Merkle tree. People build a binary hash pointers, right? Let's say you have data, right? This data, this every day, you know, each data would be different. Maybe this one would be a small file, 100 bits. This would be a big file, maybe 1 million bits in it. Maybe this one with 1 billion, right? If you want to make sure that nobody has changed anything here, what you can do, you can take a hash of this and put it here, and hash of this, you can put it here, right? Then you can take a hash of the whole data into a new hash, right? So you can have a 1 million records or here, right? Let's say you have 1 million records. But if you traverse through this tree, you will have a single 256 bit, right? As long as you have this, the message dies, this 256 bit, you can able to ensure whether somebody has changed something here or not, right? If somebody, an attacker change a bit here, from, let's say she changed some information here, this changing this one single bit will completely change the output here. Okay, so the people can easily verify whether data. Also, if you have this binary tree, you can able to search. If you have a 1 million record, right? If you don't have a binary search tree, something like this, you need to write a for loop, right? From 1 to 1 million, it will take much time, right? But if you build a binary search tree, something like that, you can find the single document in log to 1 million. So this is much simpler. I think if you log to 1 million is do a calculation and let me know. But if you have a search tree, something like that, you can search this 1 million document in a fraction of second. Otherwise, you need to spend long time. Okay. I think these are quite important aspects of hash, and I will stop at this point, right? We will dive deeper into these other two security mechanisms next time. But so the hash is the key technique used in blockchain to make sure its security and efficiency, right? And so you have, I will stop at this point. We will go through the remaining later, but if you have any question, please ask me now. Do you have any questions, students? So you have my emails, right? Feel free to write to me. Okay. If you have any specific questions, feel free to write to me, and I will respond as soon as possible. Okay. But we got around few minutes left, and do you have any questions? Okay. And I hope I assume some of you might have heard about Bitcoin blockchain, and some of you might have some kind of knowledge, a level of knowledge, maybe basic or intermediate knowledge in Bitcoin, right? And please let me know what important thing that you learned in this 2-hour session. If something, if you found something very useful, feel free to give me a shout. I will be very happy, right? So otherwise, what we will do next week is we will go through that remaining the digital signatures and the public infrastructure. I'm sure you have studied this one in the previous last year, so it would be give you a quite refresh, and we will see how the blockchain is putting these three technology together to build an innovative, like a groundbreaking blockchain technology. And we will answer some of the question is how the blockchain Bitcoin is ensuring that nobody can able to double spend the cryptocurrencies. As I mentioned before, if it's a paper cash, you can't spend the same cash in two places, right? But if it's a digital, you can copy and paste in multiple. So how this is stopping you from doing that? And second one is how the whole system is working, right? You may heard about miners, you may heard about China. Is actually there are a lot of people in China making a lot of money in Bitcoin, and we will see how they are making sure they are earning rewards as well as making sure the system is secure. Okay, and I will stop at this point. Hope it's okay. Is that okay, Dr. Ramanan?
Yeah, fine. So, sorry, I would have missed. There was a question from Miss Divya. Have you read it on chat? She is asking, sir, you said that Bitcoin is decentralized and no one has control of it. Then why it has got the limitation as 20 million coins?
Yes. Yes. Let me repeat. I answered this one. Let me repeat this one. Like this is actually okay. There are one more question, because similar to our IP addresses are 16-bit, and now we are IPv6 32-bit. When the Satoshi, the inventor of the blockchain, he built the software will only allow 21 million Bitcoins to be produced. So that is the fee that is inbuilt within the software, right? So similar to IPv6, it is fixed. Nobody can change it, right? And the second one is, even if Satoshi Nakamoto, the inventor, comes alive now today, right? He can't able to change anything, and he can't able to control me using, because we are all equal, whether it's a Satoshi Nakamoto, the inventor, or Divya or myself, we are all equal in this nature. That is the beauty. So 21 million is, you can treat this as the same as like a 16-bit IPv6, right? It's fixed because of the that's how it is actually built. Okay. And the second, there's another question from Fauzi Ghaffar. If there's an encryption algorithm for the hash function, why can't there be any decryption algorithm? Because you can't, because you are compressing the data, right? That is a whole big new theory, right? I think understanding how the hash function works is like another, is a one module, but you can trust that it is like a one-way function. You can actually go one direction, but you can't go back. And it's a similar technique, like it's the same similar technique used for public key infrastructure, right? It's public key infrastructure. It's using like it's similar to one-way hash function, but public key infrastructure has a key so that you can reverse it. But in hash function, and particularly the hash function is not an encryption. Okay, hash function, the SHA-256 is not an encryption. Okay, so that's if I mention, if I mistakenly say it is an encryption, please apply it. Hash function is not an encryption. Okay, hash function is a one-way cryptographic scheme, right? You can give any amount of data as an input, and it will always output 256 bits, and there's no way you can go back. It's a one-way hash function, right? Hope it makes sense, right? It is not a it is
okay.
Not a,
thank you
okay,
very
I think
much.
time's up.
Thank you very much. Actually, students have to learn punctuality of the lecturer. He exactly joined at 1:30 and he completed his lectures at 3:30 Sri Lankan time. So there were some students request, they came a bit late and they were asking, we are unable to join the meeting. So next time, please make sure that you are on time. Punctuality is very important. And hope you had a good session. And if you have any questions, you have the lecturer's email address. You can even email him with your questions. He will be happy to clear your doubts. And then Dr. Rahula Madhavan, when shall we schedule the next class? At your convenience, please.
Shall we? I believe we can schedule next week same time, if possible.
So is it okay to have it next Wednesday, same time?
Yes, I think so. I think we can have it next Wednesday, same time.
So next Wednesday is 6th of May, am I right?
Yes, that's right, yeah.
Right, okay, so dear students, we will have the next session at 1:30 p.m. Sri Lankan time, UK time 9 o'clock. That is next Wednesday. So Dr. Rahula Madhavan, please feel free. You can schedule the classes or you can even break the classes at your convenience. There is no hurry that you have to complete it in a short time. Please feel free. You can break up the sessions as you wish. And we are happy to facilitate these lectures. So students, do you have any other questions before we conclude this chapter today?
I think there are a couple of students are quite active and I would expect them to send me emails. Otherwise, there are a few students, I can imagine they are year 2 students and it's completely, even though it's not too difficult to understand. So I'm sure someone or kind of inspired by the where the world is going towards in terms of this blockchain.
Yes.
So,
so interesting because the students have also studied, as you have seen, cryptography in their first year. So they have some basic understanding about these concepts. So I hope they would have go through your slide before attending the lecture. So shall we then conclude today's class?
Yeah. So yeah, thank you. Thank you very much. Thank you all.
Thank you very much for your time. So we will meet again on next Wednesday, same time.
Sure. Yeah.
Okay.
Thank you.
Thank you.
Bye-bye.
Bye.
Take care.
Bye. Take care.